gotta look at a couple things here now with your cost notes again. Yeah, this is not something that you need to study necessarily. What you have to remember now, though, as I move forward, okay? Here, remember, there's one thing that is gonna be an easy question for you. DMR, is that phenomena a short run or long run phenomena?
Isn't that short run?
We need to work right here. Yeah, that this is a short run phenomenon. You just remember Betty's Bakery, correct? So if I draw a short run average cost curve, short run average cost function, as we then add more labors to get more quantities, remember why it drops and then rises again? You're becoming more efficient, correct? So I see a lot of questions regarding DMR and economies, all right, of scale. This is a what? This is a long-term phenomena, isn't it? In the short run, what is always held fixed or constant? It doesn't change, all right, with output is what? What cost?
Fixed cost.
Fixed cost, okay? In the long run, all costs are variable. And so in the long run, we would have all these short run cost curves. This is economies of scale, meaning that you are gaining more efficiency from large scale production. You know, you're adding on to your firm, you're buying new ovens, correct? Short run, you add more workers, you're gonna run into what?
Sorry, Maddie's sick.
Serious?
One of them is veggie. Yeah, she's throwing
Oh,
up.
well, you didn't have to do that.
Maybe Lily's back.
Darn it.
Okay. But does
Dang.
Maddie have 2 solos? She took Lily's. Okay.
So I was gonna take Lily solo. You?
No, Lily's back. So Lily's gonna get her solo.
There's a veggie there for you. Hello, crayfish. So, is anybody confused by this then? Short run phenomena, long run. Economies of scale. What would you call this then? Diminishing returns? These would be increasing returns. Make sure you get that, you know, this is a real simple question. Increasing returns, diminishing returns. Right? You keep adding people to get more output, you're gonna run into your average cost. You're not efficient. Remember we had Pop, all right, beating people with the blender or something. But in the long run, more technology, bigger, okay? So that's why I threw this up here. The only thing I want you to remember with this is gonna be really important now when we go over, when we're gonna go over the pure competition model today. You know what explicit and implicit costs are. Implicit costs are your opportunity costs. You have to think like an economist. And this is where I want you to look at this right here. All right? Everybody in here knows that accounting profits are going to be larger because they don't take into consideration, right, opportunity costs. Now, let me show you a couple of examples here. All right?
It's not technically school though.
You're in my house. Your tolerable teacher bought you a pizza. So, there you go.
Thank you.
All right. Looking pretty dapper today. So take a look at this, you guys. You want to make sure that you know this. This is very important. All right? If you look at case 1, here's your explicit costs. That's your cost of business, where you're buying, all right, the glue, you're buying the lacquer. Depreciation is always called consumption of fixed capital, if that shows up on a test. I don't know why they use these terms. It's usually a macro thing, but you can see it in micro. Do you know what depreciation is? If you buy a tool, all right, as you use it each year, does it wear out? Okay, everybody knows what depreciation is. the consumption of fixed capital. So we're gonna call those, all right, our explicit costs. Now, to an accountant, all right, you made $35,000, you made $35,000 regardless of each one of these case studies. What we're trying to show you is economic profits. Okay? And if we take into consideration our opportunity costs, that's really, all right, what else we could have done. Right? What else could we have done with our capital? All right, and what else could we have done with our time? In this case, all right, Babbitt could have, worked as a chef somewhere else rather than opening their own cafe. They could have, all right, used all of that money to start the business, all right, and put it in the bank and earn interest. That would be their next best alternative. So you'll notice what this really means is when your accounting profit exceeds, whoops, right over here, my apologies. When your accounting profit exceeds then your opportunity cost, are you showing an economic profit? Yeah. When you are not, you're at an economic loss. Now, should you continue to then, this is going to be the tricky part for today, you're showing an economic loss. Should you continue to then operate in that business? Yes. In the short run, do you think there are businesses out there that operate at economic losses every year? Absolutely. Okay? Remember, I don't believe Google has ever turned a profit. I told you Musk didn't turn one until a couple years ago. He's getting all those pollution credits. And you're thinking right now, well, you should get out of business. We're going to show that to you, all right, in this unit. But just keep that in mind. What you're really doing, remember, is you're comparing what else I could have done to what I'm currently doing in my accounting profits. Now, here's going to be the magical thing, right, when we start this today. The magical thing is zero economic profit. Okay, so notice now, we had case one, here's our accounting profit, but then when we looked at what else we could have been doing, when we add in our opportunity costs, we actually have a negative value. Doesn't it really mean that we could probably make more money doing something else? Do you guys see that? 34 and 3 is what? 37? Our opportunity cost, what else we could be doing, is greater. So we're operating at an economic loss in that situation, okay? But what if our economic profit was 0? Because I'm going to tell you in a second here, in pure competition, all right, economic profits will be 0. You have to understand what that means. You're covering all of your costs of production plus what else you could be doing. Does that make sense now? Now, we call that a normal profit. You are going to see that all over in that Clep test. Okay? If you are earning, now let's think about that again. If you're earning a normal profit, it's 0 economic profit. You're covering what else you could have done, correct? All right. So that's the main thing before we move forward here. I don't think I have anything else here. You know, long run, short run. The only thing I'm worried about, okay, I am worried about this marginal physical product graph. You know, when you guys did, a lot of you did well on the test, but a lot of you did not. All right? So remember, when we were looking at why are average marginal cost curves, marginal and average cost curves U-shaped, this is short run. Okay? We're going to add more labors to get more output, and when we do that, remember, diminishing marginal return, we're not getting as much output per unit of input. You have to be able to, all right, look at a graph like this and understand what this means. Now remember, this is not hard. This is a marginal physical product graph. This right here shows us why this occurs. Betty's Bakery, she added Betty, then she added, all right, perhaps Lit, Then we added, all right, John's life's looking good. Are we getting more output per unit of input with each labor that we add? We are. Remember, in the short run, your building expenses are fixed, you've got your oven, you've got your machines. Now we're adding more people. Okay? Where do we see diminishing marginal return? With what labor? All right? With what labor? E is showing us how many jackets the labor can offer us. What labor? Labor number what? 4. Total jackets produced with 1 labor is 1. Total jackets produced with 2 labors is 2. We got how many more units of jackets when we added our second labor? We got an additional 1, all right? That person added 2 rather than 1. We have a total of 3. We add the third labor, that person brought us an additional what? 7. Well, actually, my apologies, total 7. Brought us an additional what? 4. Okay? But when we added the fourth person, yeah, it's growing, but we didn't get as much output per unit of input. And remember what that signifies. And you can look at this graph right here, all right, if you would like. It just shows us once again, marginal is how much output we get per labor. If total's 1, and then we have 3 as a total, after 2 labors, we gain 2 per unit of input. And remember what this identifies. This is really cool right here. And take a look at this. It's just showing us what's our marginal then output with our first labor. All right, and then we move from 1 to 2. All right, we get 2. This is a marginal product curve. What's really interesting is right here, when we move from 3 to 4, notice instead of getting 4 per labor, now we only got 2 per labor. So our marginal product function falls, and then what should happen to our averages? Our average product should also fall, shouldn't it? Marginal always dictates averages. And if you're really good, isn't this really what we're saying? Our average cost functions and marginal cost functions are really just a reflection of the marginal physical product curve. Add more labors, did the marginal product of each labor increase? Our average then that we're getting from each labor should increase. Add an additional labor, oops, it starts to fall. So what happens to our marginal cost? It starts to rise. I've seen questions like this before where they're going to ask you, all right, when the marginal product curve passes through the average product curve, what does that represent? Well, it represents where marginal cost is going through your average cost curves. So you should probably, take a look at that. Does this graph look okay to you? Okay. They're a reflection of each other. All right, so let's get rid of that crap. Those would be some easy questions. Where you just have to know the terms. Let's do this. Pure competition. If you can do well, if you can just listen and do well in these next 2 little sections here, there are a ton of questions on this test. Okay, so did you get this right when you took your little quiz here? I put worms for fishing, like think of earthworms. Is it a pretty good example of pure competition? So find them anywhere. Mm-hmm. Go outside, pick them up after rain, take a shovel. How are you going to advertise that my worms are better than your worms? Bigger. Maybe, I got an idea, maybe you store your crawlers in some marijuana bedding, okay? And maybe they're a little bit more squiggly, okay? You can advertise that. These have been stored in meth, okay? They're lively, they'll catch more fish. But for the most part, all right, a worm's a worm. So, no barriers to entry, right? The product's pretty much all the same. Boy, are you gonna have much control over price. Okay, so that's why I threw that on that last quiz. All right, we don't have, the only thing I want to talk about here is this. All right, your teacher didn't do a very good job explaining this. Some textbooks, you're going to see this on the Clep test. Imperfect competition. Now what they do is they lump all of these forms of market types and call them imperfect. There is only one type of perfect competition. Perfect competition. Everything else is imperfect. Now, if you don't know what that term is, you're kind of screwed up, aren't you? And I said, gee, well, my teacher just talked about the 4 types. What's this imperfect crap? Well, we lump it all together for those other 3 because they're not perfect. So what, I'm serious, this is the biggest item. Most of the questions are going to be about pure competition. Now, we don't have to look at any of that crap. This is what you'd actually have to do, all right, with a more advanced class. We have to get into more detail here. All right? I have seen this question pop up more times. All right? They're going to ask you, what is the supply function for the firm? For the firm, not the industry. What is the supply function for the firm? And the answer is going to be the marginal cost function above the average variable cost function. Now you're saying, Stock, well, how am I supposed to remember that crap? But just think about what we're doing here. Don't remember it, just think about it. All right? I'm going to tell you in advance here. There is, all right, there is no productivity below, all right, that price level where it's equal to the, you're going to notice here, average variable cost. You're not going to be in business. We're going to talk about it here in a second, but you are not in business. What are your variable costs again? What are they? What's a variable cost?
Costs that are the same amount in the short run.
Okay. Could it be labor?
Mm-hmm.
Could it be the fertilizer for the golf course? If you cannot cover those costs, should you get out of the business? In the short run, yeah. If you can't pay your workers, if you can't pay your variables in the short run, you should shut your business down. You're suffering losses, okay? That doesn't mean you should exit the industry. Remember I showed you that example earlier? Companies, all right, have losses. There's a difference between short run and long run. In the short run, if you can't cover your variable costs, you are not in business. That is why the supply function for the firm, not the industry, it's the marginal cost function above ABC. So I want to hit that home right now. That sometimes pops up as a question. Okay, so here's what we're going to do now. This is really important. This is going to be the demand function, all right, for the individual firm. If you have 1,000 makers of those sticks, okay, this is the demand function that they face. It's really easy entry, all right? Anybody can do it. We're going to assume today that all sticks are identical, and so remember, you are going to be faced, all right, with one price. You can't charge more than the price if the stick is $15. Because you can't advertise that yours better. Okay, got it? All right, when we start this now, when I talked about costs earlier, and I was looking at your, all right, we were looking at your economic profits and then your accounting profits. Remember, economists always take into consideration your implicit costs. So every time we are looking at a graph in here, we're assuming that our cost functions include our opportunity cost. All right, that's what we're going to assume in here. Not the cost of production, but our opportunity cost. You can charge the price that the market is establishing, but if you try and charge, okay, $1 more, I think in class we did something like this, all right, $3. I probably didn't draw this, but I'm going to draw it today, okay? I think I drew something like this. In a perfectly competitive model, if the price is $3, I can't charge $3.01. Why would somebody pay 1 cent more when it's all the same? Why would somebody pay, all right, $1.01 for $1 if they're all the same? Okay, you with me on that? Now remember, what did I say before? You can't charge $2.99 either. Because everyone in the industry will be working, that price will be what? Equal to, what else you could have been doing? If you start going below than this, now are you earning zero economic profit? You're not, are you? Now you're at economic loss. So zero economic profit is covering all of my explicit and implicit costs. That's why I set that up for you. But remember, the market is dictating the price. Now that's going to be different as we move ahead on Monday, all right? Because in monopolistic competition, you guys have some control over price. You do, don't you? You can advertise your differences, but you can't in pure competition. This is pure competition. Okay? Markets dictate this price. So you're going to notice, and that's what I was looking for in that extra credit question on your test yesterday. Okay? If individuals leave, all right, the marketplace, what's going to happen then is Joe going to produce more or less of a product, and I'll show you how to do that. Okay, so if the demand for a product would pick up for sticks, the price would rise, wouldn't it? Okay? So keep that in mind. You idiot. Over here. Okay, so let's look at this now. When you're going to know right away, all right, if it's a purely competitive model. Sometimes they'll have graphs and sometimes they're going to have tables of information. All right, you're going to know right away. Let's do it right here. Let's try something right here. 2, 3, 4, 5. Regardless of how many items I produce, okay, we're going to look at, this is price, but it's also what? Is it marginal revenue? How would we find marginal revenue here? Well, I think marginal revenue, isn't marginal revenue the change in total revenue? Each time we make an item, isn't that telling us how much more revenue we're gaining? Is that right? So if I did this, okay, Q is going to be 1 item, 2 item, 3 item, 4 item. How do we get total revenue? Q times what?
Price.
Times P equals total revenue. Okay, so what's the price? $3, $3, $3, $3. So my total revenue is 3. My total revenue would be what? 6. My total revenue would be 9. My total revenue would be 12. Oops. So what's the marginal revenue now each time I produce another item? It's 3. Would anybody like to tell me also what's the average revenue? Total revenue divided by quantity. Well, that looks like 3. What does that look like?
3.
3. That looks like what? In pure competition, this is so easy. The price is also the marginal revenue, which is also the what? The average revenue, which is also what? The demand function. It's that simple. Okay? Who's confused by that? Pretty easy, isn't it? Okay? That's why they have D equals MR equals AR equals B. All right? So that's pretty easy. Let's do this. Okay. You can check this out in calculating it. Don't ever make this more confusing than it is. All right? How do we determine marginal cost? Didn't we just look at the change in total cost or variable? How are we going to find marginal revenue? It's just a change in total revenue. All right, so it's not very difficult. Let's do this. Okay. Now, remember I said sometimes they're going to show you pictures of graphs, sometimes they'll be tables. You always know that this is pure competition right away when the price is always what? She's always the same. Marginal revenue is always the same. Here's P times Q, that gives us total revenue, and then we can look at the change when we're producing each one of these, and our marginal revenue is 131. Okay? Marginal revenue is constant. What is average revenue for the firm? Okay? What happens if the firm charges $132? That would be like saying, what happens if the firm charges what? $301. The market established the price of $131. As soon as you see that the product price is constant, regardless of how many items are being produced, you know right away it's pure competition. So what happens if you try and charge $132? You will not sell anything. This tells me the products are all identical. Fair enough? Okay, so let's try this. Okay. Here is your profit maximization rules. There's two things. I told you last week, profit maximization or loss minimization is MR equals MC. Profit maximization. Or we can put up here, it's bad handwriting, minimization. All right, same thing, okay? MR equals MC, what's the other thing you can do? I saw Pop working on this yesterday on his quiz. You could have done both things, couldn't you? On your little quiz, did I ask you, all right, if I'm not mistaken, how many products should the firm produce? And there was a table there, right? You should have produced, I believe it was it 6 items at $4? Okay, and I saw Pop going through the table. I saw you doing this. So you could have determined what was the profit maximizing output by either looking at MR equals MC, I think some of you did that, or could you have looked at the total revenue minus the total cost? Now sometimes, depending upon what information they give you, all right, you might have to use one of these 2 items. Okay, does that make sense? All right, look at, it is valuable to understand both methods for profit maximization. I don't know what table they're gonna give you, correct? If you look at this table right here, do they give you marginal revenue?
No.
Do they give you marginal cost? Now, you remember, it's a time test. Could you convert this so that you knew the marginal revenue, marginal cost? How would you do that? How would you do that, you guys?
Find the change in total cost,
Yeah,
then total revenue.
absolutely, tell me. What's my change in total cost here?
$90.
And,
80.
and?
70.
I can't read that.
So if I complete that column here, I'm gonna have my marginal cost, and then could I have my marginal revenue? I could, couldn't I? Yeah. Could I find out that 9 units is gonna be where we should produce? We should produce that output. Yeah. Now, right now, I know that's the right amount because we merely took what? Our total revenue minus our cost. We went right down the list. And it seems to me we would maximize our profits at the 9th item here, correct? Does everybody see that? Okay, so then let's say they you know, and you want to be efficient on the test. If you don't have to convert it, you don't want to. All right, you might see a graph like this. They do this to you sometimes. What does this graph represent? And then they might say, okay, what would be the profit maximizing amount? Well, it'd have to be a really, really easy scale though on X and Y, because remember you can't use a calculator, but it would just be the greatest distance between your total revenue and total cost functions. Why is this total revenue function a nice flat line, or not flat, but why is it a linear function? Why is that? Because it's what? It's pure competition, right? Every time I make an item, how much money am I going to get for my product? $131. Okay, pretty simple. And then look at my cost function. My costs fall, but then they rise again. Can you see diminishing marginal return on here? Yeah, I see all of that stuff. It's a U shape. All right, it's good stuff. The firm has absolutely no control over price. What output will it maximize its profits? That's what it's going to decide. Okay, here's your MR equals MC rule right here. Now we can do the same thing. Let's take a look at this once. Didn't I ask you just a second ago, couldn't I come up with the marginal cost and marginal revenue from that other schedule, that table? Yeah, well now they gave it to us here. So when we produce our first item, is the marginal then revenue greater than the marginal cost? Yes, it is. So I want you to remember, whenever MR is greater than MC, should you produce more or less? If your marginal revenue, when you're going to make your first widget, marginal revenue is greater than marginal cost, should you keep making more?
No.
No.
If your marginal revenue that you're getting is greater than your marginal cost, should you make more?
Yeah.
You make more. If the marginal revenue, or I could, we can go less than marginal cost, or I could do this. If the okay, if the marginal, all right, cost is greater than the marginal revenue, what should you do? You should not make as much, less. We'll show that to you here. Marginal revenue greater marginal cost, marginal revenue greater marginal cost, okay? We're going along. Let's go down to our 8th unit here that we produced. The marginal revenue is 131, marginal cost is 110. Should we keep making some items? We should, shouldn't we? We make one more item, look at this. Marginal revenue is equal to marginal cost. Well, it's close, isn't it? That looks like that might be the right item, 9. But take it a step further. Oh, now the marginal cost is greater than the marginal revenue. We made too many, didn't we? Back her up. Pretty easy? Okay, let's do the next item here. All right, here's the fun stuff. Okay. So what does it look like when you have economic profits in the short run? Now, I'm going to cheat and I'm going to go ahead here a little bit, okay? I'm going to go over here and let's try this one. I'm going to show you the long run equilibrium. I think it might be helpful for you to see that right now. Where would I draw that marginal cost function?
So it goes right through the middle.
Very good. Has to be that way. And what is this again?
Marginal return.
This is going to be
Or demand.
our price, but what else is it?
Marginal revenue.
It's our demand. What else? Average revenue. And what else?
Marginal revenue.
Do we always produce where marginal revenue is equal to marginal cost? That would be right here, correct? Let's move that over a little bit. 3 units is where they will maximize profits. Okay? We're pretty good so far in that? Who's confused by that, you guys? That's your long run equilibrium. That is where, in the long run, prices will always go. Now, this is why pure competition is so unique. The price that you pay in the marketplace is equal to the marginal cost of producing it, and it's where, at the minimum efficient scale, it's equal to ATC. Now, that's long run. I'm going to write right here, long run. What we're looking at right now is the short run. Well, what can happen in the short run? Well, there could be changes in the marketplace. Remember, this is the individual who's making those sticks. This is the demand curve that they face. They can only charge one price. But what actually sets that price is the market. Okay? I want you to understand that. So, can economic profits occur in the short run? Can they? Yeah. Watch. In the short run, is it possible that the demand for the product has picked up? Is it possible? Yeah. Well then, price would be where? It would be here. Look at where price is. A lot of kids didn't get this right on that quiz. Shecky, you want to start that now, bud?
Yeah.
Shecky, go over there. Spread yourself out, okay? A lot of you didn't get this right on that little quiz yesterday. We said, all right, that we're gonna produce that what? MR equals MC. Does everybody see it now? That's MR equals MC. The only problem is you're gonna notice at the 9th item that you're producing, what's the average total cost of producing it? The average total cost of producing the item is $97.98, but the price you're getting is $131. You're gonna produce 9 items, and for each item, you're getting a profit of how much? 131, and it looks to me like about what, $12.22? So could you guys figure out then the profit for this firm in the short run? Could you do that? Right, that's all you're doing. Now, if you're smart, if you're really smart, if profits are ever shown in a competitive model where everybody can make it and there's no barriers to entry, it's so easy, all right, that you can just go out and pick worms up off the ground. What do you think's gonna happen in the long run? You tell me, what do you think will happen in the long run? If it's so easy to make, it's pure competition, there's no barriers to entry, and people are earning profits. Brock gets up, what the crap? All right, look at that money that they're making for picking those worms up off the ground. What's gonna happen?
Other people are going to join in.
Profits are being earned and it's easy. Exactly, John. So are people gonna enter the industry?